Yo. So you want us to speak a little bit before we start the video, or just
Yeah. Welcome everyone. All ye digital cash fans, and I know there are many of us in this Dash community. That's what Dash is all about, digital cash. So today our topic is CoinJoin in JavaScript implementation of CoinJoin, which AJ, our guest, has been working on over the past few weeks. AJ, how did it go?
There was a lot of good documentation for the individual messages. And so when I saw that, I was really excited. And I thought, oh, man, this is going to be so quick and easy.
I think you used the term cakewalk or something,
Yeah, well, once I was
words.
getting to the last message, because there's a couple places where the documentation is ambiguous, like the grammar, like is the comma here or is the comma there? Are we eats, shoots, and leaves, or eats, shoots, and leaves? Like, there's a couple of those things. But other than that, I thought it was going to be really easy. But it turned out that there was a single misplaced byte that I had that took me a long time to find, because I needed a reference implementation to be able to see, okay, from someone who's actually got this working, I need to see the bytes that go across the wire, because my tests are passing. I'm doing what the documentation says. So anyway, there were some messages that there weren't references for. And so once I got the references, then I was able to complete it. And if I had those to start with, then it would have significantly cut down on the dev time. And there's a few things I was unfamiliar with. There's a few things that aren't in the documentation. Like, for example, it says that you're gonna send message A and you're gonna get back message C, and then you're gonna send or B, and then you send message C. And so there's this 12-step handshake. But one of the parts that isn't listed in the handshake is that one of the messages you only get if you send a previous message before any of the process starts to say you want to subscribe to that type of message. And so, there's a couple things like that where, just how many people have used the documentation for this? It hasn't had a real good run through.
Yeah, and I will say that I think that some of that struggle that you went through, it did have some good consequences in that you had to build some tooling and testing around our transaction libraries so that you could see exactly what was going on. So I think some good came out of that struggle, in addition to the end result, which is a working implementation of the protocol.
The byte that was wrong was in -tx, and it was because it was in a code path that was never executed in any other way that we've ever used it.
Yeah, exactly. So let us back up a little bit and introduce the topic a little bit more before we delve into some of the details. I wanted to show an 11-minute video of Amanda explaining the process and what CoinJoin and what PrivateSend is all about. Just as a heads up, some people in the Dash community use PrivateSend and CoinJoin synonymously, but as we'll talk about later after the little video, which will set the stage, I think that they should be considered a little bit differently, just in terms of being able to talk about the different steps of the process. So let's show that video, Anthony. If nobody else benefits from this, maybe you will, since I don't think that you really know what this feature is, but it is one of Dash's flagship features because Dash is aiming to be digital cash. And as we all know, digital cash or cash itself is private, instant. And that's what we're trying to replicate in the digital realm, because we've always had that historically. We've always had the ability, humans have had the ability to transact with cash. And now that we're moving into the digital age, we want to preserve that. So very important stuff here. Let's roll the video.
Yeah, and just before that, I will say, I think it's interesting that because of the transition out of cash, if cryptocurrencies don't do this, we'll essentially lose this ability forever, like society-wide, which is kind of a scary thought.
Exactly.
Yeah. All right, here we go.
Hello, and thank you for joining me in front of my marker board for this special episode of Dash Detailed, which is an explanation of how PrivateSend works under the hood. Before we begin, let's establish again why privacy on an open ledger would even be an issue. So for an example of a standard non-private transaction on an open ledger, go ahead and take a look at this Dash transaction. If it were known that this address belonged to Mo, for example, say he had given it out in an invoice, or even put it in his tip me area on his Twitter profile, something like that, then we would be able to follow that Dash on the ledger, both where it had been before Mo got it and where it goes after Mo has it. And the reason for that is the structure of the transaction on the ledger. One known single address sending the entirety of its contents to another address. Compare how that non-private transaction looks with this PrivateSend transaction. Now, whereas we may know that this address belonged to Mo, again, because he published it publicly on Twitter or put it in an invoice or something, we now have no idea which of these many output addresses now belong to him. Is it this one, this one, this one? We don't know, and that's the point. If Mo puts his Dash through this type of transaction multiple times, one after the other, what we end up with after these mixing rounds, more on that in a moment, is a practical mathematical impossibility of tracing where Mo's coins go anytime in the future of this ledger. So, how it works under the hood? Here we go. The first thing that happens when you tell your Dash wallet that you would like to private send mix any amount of your coins for future private use is that it breaks them down into denominations that will be uniform with other users on the network. So let's say, for example, you have 10 Dash you would like to mix. Your wallet will now break down this 10 Dash into denominations of 1, 0.1, and even 0.01 Dash. And as you saw in our earlier Block Explorer example, each of these denominations, of course, lives in its own newly created address. Etc., etc. You know how addresses look. Once you have these newly denominated bits of Dash, each sitting in their own address, your wallet now consults its list of masternodes. Your wallet maintains its own list of the network's masternodes, of which, of course, there are several thousands. Your wallet also knows which masternodes you have used for mixing recently, and so will not use those. Something like that. Your wallet contains a randomness generator called OpenSSL RandBytes. Don't ask me what that is, I just work here. And it uses that utility to pick from among the remaining masternodes to select one randomly, which you will then submit a mixing request to. There we go. At this point, your wallet sends a mixing request to the masternode it selected. In this request, your wallet states the denomination or denominations it would like to have mixed. Granted, it doesn't send the private key to this Dash, just states how much Dash it would like to mix, as well as including a small piece of collateral / fee. More on that later. The masternode then creates what's called a session ID. And this session ID contains the necessary information, basically, hey, I'm looking to mix one Dash here, contains the necessary information to broadcast out to the rest of the network so that that information can reside in what's called the mixing queue. The rest of the network, any member on it looking to mix one Dash themselves, their wallet will consult this mixing queue to see if there's a match. Changing your wallet here to Mo's for continuity of the story. Once the wallets belonging to Mo, Larry, and Curly all respond to this mixing queue because they all have one Dash they would like to mix, the session is ready to start, as 3 participants are required. To initiate mixing, the masternode then sends each of these 3 wallets a message that essentially says, ready to mix. At this point, each of the 3 wallets tells the masternode 2 pieces of information. Their input, that is, where the 1 dash they would like to mix currently resides. And secondly, their desired output, that is, which of their own newly generated and empty addresses they would like their 1 dash to end up in once this is all said and done. The masternode then checks that all of these requests are legitimate, basically that the inputs are not already spent and that this setup is indeed a spendable transaction. And if it is, the masternode combines all of this data into a ready-to-send transaction that is 1 dash, 1 dash, and 1 dash, ending up in new addresses 1 dash, 1 dash, and 1 dash. But the masternode doesn't send this transaction out to the network as a real thing just yet. Why? Because the wallets need to check that the masternode has done this correctly and is behaving honestly. So the masternode sends this transaction just to those 3 wallets, and those 3 wallets check for 2 things. One, that the output dash equals the input dash, meaning the masternode isn't trying to steal some of the dash for itself. 1 dash, 1 dash, 1 dash, yes. Outputs equal inputs, good there. And the second thing that the wallets check for is that their input and output that they originally submitted, that is their address where their 1 dash currently resides and where they'd like it to reside, they make sure that those addresses are accurate in this transaction as well. Again, to make sure that the masternode isn't trying to send some dash to itself in a sneaky way. Mo will see that his input and output are correct, check, though he doesn't know which addresses belong to which of his mixing partners. Again, that's the point. Larry's wallet will see that his submitted input and output are both correctly recorded in this transaction. And Curly's wallet will see the same. Once verifying that this transaction does indeed look correct, Mo's, Larry's, and Curly's wallets will each sign it with their private key, which is totally normal and how cryptocurrency transactions work in general. But this is a slightly different special signature. You like those signatures? So what these signatures say above and beyond what a private key signature usually says in a cryptocurrency transaction is that it is all right to send this transaction regardless of whomever else signs it. Because of course, Mo doesn't know Larry's private keys, Larry doesn't know Curly's private keys, and etc. So they need to sign this transaction, they need to say it's okay in a way that allows the other 2 to sign it without any of them needing to know each other's private keys. If Mo's, Larry's, and Curly's signatures all check out, the masternode now broadcasts this transaction to the rest of the network for real. It will now get processed like any other regular Dash transaction on the ledger. And bear in mind that if at any point before broadcasting it, the masternode attempted to alter the contents of the transaction, again, in any way to be dishonest, to attempt to send any number of Dash to a place where it was not authorized to go, the signatures of the participant wallets will be invalid, and so the transaction will not go through. After the masternode sends the broadcast, Mo, Larry, and Curly will see their Dash is in pending. It's in their wallet's pending area, which is where any and all incoming Dash go while they're awaiting a confirmation. And, of course, in this way, none of these participants ever had to revoke their private keys at any point along the process of mixing. The wallet participants have now created for each of themselves an uncertainty set of 3 addresses. Where did Mo's coins end up? We don't know. Where did Larry's? Where did Curly's? We're not sure. And because this process can be repeated up to 8 times, you can begin to get an idea of the size of the uncertainty set that it creates. If this sounds like a less than perfectly intuitive process to you, don't worry, it is, which is why evolution is being designed to make this pretty much obscured away. That is, one ought to be able to simply put any amount of Dash into one's private account, and all of the rest of it just happens. But in case you're the kind of person who likes to know how things work under the hood, there is Dash PrivateSend. And now, what about that collateral/fee I mentioned earlier that always gets submitted with denominations to be mixed? It's almost always returned by the masternode to the original submitting wallet, though roughly 1 out of every 10 times it's kept as a way to prevent abuse to the system. Come back next week, same time, same place, Wednesdays at 12 noon Eastern Time. See you then.
Okay. Well, I don't think 12 noon Eastern Time. Actually, 12 noon Eastern Time is the time that we're doing this.
That was great. It was a really well done video. I like that a lot.
Yeah, so I'm glad that you saw that. I think it will make the discussion a little easier. One of the things that a few takeaways that I wanted to make note of. So as you can see from that explanation, the masternodes are performing a completely non-custodial service, and they're pretty much exclusively what they're doing is they're facilitating communication. They're sending messages back and forth on a peer-to-peer protocol, but they don't ever hold any of the funds from participants. It's just communication. And one thing that, another thing to note is that the only fee involved with that is preventing abuse of the system. So it's not like a fee that they're collecting. So the masternodes are performing a service of communication facilitation, and they've been doing this for a long time. So what we've done, what we're talking about today, is that we've developed an implementation of the client side of this service communication in JavaScript. And one of the benefits of having done this, I think, is that we've pulled out all of the functionality of this particular protocol into a standalone library that can then be used as a reference for other languages to follow. One that I know of already is somebody is interested in implementing this in Dart. So they would be able to take this reference and pretty much be able to say, okay, I know how this protocol works. I know what messages to send. I know what format to send these in, and I can implement this in the Dart programming language or whatever programming language. So AJ, I know that was one of the things that you were excited about as well. So I did want to say, actually, I'm going to have you say it because you're the one that kind of brought this up to me. The other thing that I wanted to note was the difference between CoinJoin transaction and a PrivateSend transaction. We use them synonymously, but can you tell the audience what you've told me about what distinction we should be making here? Because they're two separate things. You're muted.
There we go. I found it. Yes. So, the name kind of says it. It's pretty obvious from the name. A coin join is when you're doing a process of, well, it's more of a coin unjoin if you really want to think about it, like what you showed. That's the coin mix process is coins go. They are joined in the sense of joined in a transaction, but they're actually, mixed. They're unjoined as they go out. And that is not actually how you send money to another person. Now, she referenced something that I had forgotten about, which is that some feature of evolution, which I don't know if the current incarnation still has that as one of its features, but that it had a different way of doing the private send, which sounded like it might be synonymous. Like in that iteration, that whenever you wanted to send money, the sending money would actually be a mixing process as well. That's what that video sounded like. But I don't know anything of that. I haven't seen any documentation on that. It seems intuitive enough. But private send is when you use funds that are not, I don't know what the right word is to use, because I hate talking about this in terms of quote unquote privacy, because I think that's the wrong lens. This is, but funds that are not that are more cash-like in nature, let's say, and you just select from that pool of funds when you do the send, and you don't have any return change. So a private send is there's no return change, and the funds that are selected to go into the private send are funds that have not become vulnerable to disclosure.
Yes. So one thing a couple things to note here is, so to summarize, a CoinJoin transaction is one of those transactions that Amanda just described, where you're taking inputs and outputs, you're making them equal, and basically the process is to eliminate unnecessary transaction history from the participants. That's what we would now call a CoinJoin transaction. And then the private send transaction is when you take those coins and use those as inputs to a transaction where you're sending it to somebody else and using those coins. And those transactions, they look completely different on the network. You can tell what a CoinJoin transaction is versus when a private send transaction where you're using CoinJoin transactions as inputs to and sending those look differently. Now, you and I, AJ, we've also discussed this idea of just making a cash-like send transaction where you're basically doing both of these steps all the time in one transaction, and they look the same. We won't get into the details of that, but I did want to just at least highlight that is one possible way to increase privacy. And I'll just go ahead and say that privacy is normal. Surveillance is what's abnormal. So by default, people should have privacy, and this kind of follows the principle of least. What's that called, AJ? The principle of least
surprise.
Sorry,
I principle of least surprise.
No. Like in just programming itself, or not programming, but system administration, where you only give access to people.
Least privilege.
Yeah, the principle of least privilege. You only give access
zero
to
trust
information,
security, right?
To those that really need it. And that's kind of following this principle, is like, not everybody needs to know everything about a transaction. And so it's a little bit different, but it's the same in principle.
Principle of least privilege.
So I've talked about this a little bit before, and I'll try to say it very simply. And I have dips up for this that explain, detail this out. So I'm implementing CoinJoin because ostensibly that's what the master node owners want, right? And I guess the votes will determine how far this implementation goes. But my concern is that this is like, you've broken a leg, so I'm going to give you a scooter.
Mm-hmm.
Like, the problem is that, well, like, something happened that you broke your leg in the first place. Let's try to figure out what that is, and that your leg's broken. So we need to address the broken leg. So the way I look at it is, we have security vulnerabilities in the protocol that we inherit from Bitcoin. And I think that the reason that Dash continues to propagate those is to be compatible with Bitcoin clients and to not cause disruption. Because if we fix some of these vulnerabilities, it kind of could be a two-step process, like a deprecation of the old way while introducing the new way, and then at some point in the future, dropping the old way of doing things. Like, the transactions have to be at version 3 or higher, or at version 4 or higher, or something like that. But we have this stuff that is inherited from Bitcoin that they've tried to fix in BIPs, but basically there's not been a lot of investment in the client software. So these security vulnerabilities continue. And rather than addressing the issue at the core, which is the security vulnerabilities, the things that are exposing information that shouldn't be exposed, which I think everybody can agree on. I don't think that's controversial. I don't think that if you talk to a liberal versus a lefty versus a righty versus a conservative, I don't think anyone's going to feel controversially about, hey, if we have a security vulnerability in the software that's leaking information that should have never been leaked in the first place, we should fix that vulnerability. My concern is it becomes very controversial to then say, well, we're not going to fix the vulnerability, but we're going to have this opt-in feature that you do this thing that kind of sounds like a filthy, dirty word that puts people in jail. And yeah, so I don't know. I think we should focus on fixing the vulnerabilities, but I also think that we need this implementation done so that people can kind of explore it and understand it and work with it. And in truth, no matter which direction we pick, unless it's 100%, it's not going to work, because the whole idea of, CoinJoin is, well, look at these 3 transactions, and now it blooms out into 3 other transactions, and now it blooms out into 3 other transactions, and this can be done 8 times. Well, what happens after a coin is spent 8 times without doing that? Well, all 8 times are undone, right? So you either have to have a perpetual system where everybody is preserving, protecting against exposing information that shouldn't have been exposed all the time. All the clients on the Dash network need to be doing that. Or it's not really of any value, because the only money that isn't then exposed is the money that's not spent. And if the purpose of it is cash, then you have to spend it, which means that, and up to this point, I could be wrong, but I don't think that any of the clients actually support PrivateSend other than Dash Core. I think the Android wallet is about to get it, or maybe did get it, but it's not like turned on. It's like there in a setting or something.
Yeah. So
can I ask a quick question? Actually,
do.
as the noob, try to draw a comparison. You can tell me if this makes sense or not. It sounds kind of like what you're talking about is something that has been endemic to the internet itself, where it was kind of built without security and privacy in mind, and we had to do this transition from like HTTP to HTTPS, and HTTPS always being on. So you just want to say, hey, we should have this be secure, S for security. Why don't we just do that for all of it, and then not let people have the option to not do HTTPS? Is that a good comparison?
That's a great comparison. Actually, you're reading my notes. I literally have a note that says to bring this exact concept up, because nobody would think that people should be running HTTP without the S, without the TLS security along with it these days. Everybody always uses secure practices by default on the internet. Transactions should be the same way, because they are in fact the same thing. They're all communicating. They're all just making communication. Anyway, I did want to jump into a small demo about what you've done, AJ, and then I did want to talk about like a little bit of the roadmap ahead of us after that. So let's get your screen share up and kind of show people. And while you're doing that, I will discuss why I have prioritized this specific implementation, the JavaScript implementation, because
AJ is sharing from inside his own screen.
Yeah, I know. That's how he does it.
Okay, well let's make him bigger then, and then do that. There we go.
Most applications are built on the web. I mean, that's our interface to most applications, and without having a native JavaScript implementation of this, I feel like we were limiting ourselves and limiting the applications that we could bring this to, this security feature to everybody. So that's why I thought this was important, but also because of the other things that we've mentioned, that it's an implementation that other people can then follow.
Yeah, so one thing that's different about this implementation is it is not a port of the C++ code. So a lot of almost all the stuff that I've seen is it's similar to Bitcore. It's like the people who are doing it are trying to port the entire thing. They're They're not looking at it like, okay, here's a protocol that we can isolate. And if we build a library around this one protocol, we can have it perfect. And then here's another protocol we can isolate. We build the library around it. We can have it perfect. Instead, it's like this huge mess, and you can see its age, you know, where somebody needed to do something and they couldn't figure out how to do it, and so they just like threw in some global state variable and then reference it later, and then and so it's like really messy, nasty code. Because I mean, this is all code, right? All code, 100% of code is not designed from the start the way that it ends. And so when you do a second implementation, you have the opportunity to say, okay, now that this protocol is complete and it's been used for a few years and we know that it does what it's supposed to do, let's write the code according to the result so that we have nice, clean code that speaks to what we actually did, not what was on the whiteboard before we started. And so when you have the code isolated like that, then it's much, much easier to look at just the pieces you need to focus on, and they actually do the right thing in an intuitive way, because you're not shoehorning in like, oh crap, we forgot this thing, but we're 3 years into development. Just stick it in there and make it work. You know, it's the flow is according to what the end result was rather than speculation. And so that's something that you just, I don't think in the history of coding any program was ever written the first time with all of the features and all, you know, everything done right, and they ended up with good readable code that could easily be transposed into other languages. And so that's something that I think is really important. And having code in your own language is really important, because if you don't have code in your own language, then whoops, if I can get this thing to come up.
Can you bump up your font also before you get started?
Not on that one, but I will on this one.
Okay.
Because that one's just a bunch of log messages, and they'll be.
And tell people what you're doing as you're doing command.
So I actually had to implement. So we have a bunch of tools we've been working on for the last 2 years to create a wallet in JavaScript. And this is what I was going to say, is that you should have the tools that you need written in the language that you need them in. One of the problems with the Python implementation and some of the other JavaScript implementations.
This is Electrum. Python is Electrum.
Yeah, is that they don't use Python. They use C code and C++ code, and then have a plugin into Python. So you can't actually look through the Python code and learn entirely what's going on. You have to go dig down into C code or C++ code, and that's a couple of problems. One, like, it is not intuitive how to get Electrum to run on a Mac as a developer, because it has dependencies that are unclear that depend on the C compiler and the C++ compiler, which that's not too hard to get going on Mac. That's a little more difficult on Windows. But then you actually have to have specific versions of these dependencies of things that they're not standard tools. So anyway, when you have everything in the language from top to bottom, it's either part of the language's standard library or it's written in the language, then as a developer in that language, like, I don't expect a Python developer to know C++. Like that is not, like, it is not reasonable to say, as a Python developer, you can read C++, right? No, Python is intended to be a very simple language, and it's intended to be focused on applications. C++ is intended to be a very complex language, so that you can have any manner of type of expression that you can imagine or dream of. It's almost a meta-programming language in of itself. And it's also designed to interface directly with hardware, like printers and floppy disk drives. It's not intended for writing things at the application layer. That's just kind of a side benefit of its age. You know, people have ended up using it for applications, but its design is for directly accessing hardware and memory buses. And so when you look at C++, it's like 9 out of 10 lines of C++ have to do with hardware access of memory or CPU controls. And like 1 out of 10 lines is business logic. Like, if this, do that. Most of it is like allocate memory, check the size of memory, set the memory. You know, that if you look, so as a Python developer, you're someone who's really focused on applications, and you're not focused on the specifics of hardware or the specifics of memory locations. So anyway, having, and JavaScript is kind of the universal language for better or for worse. If you can write it in JavaScript, somebody can write it in C#, somebody can write it in Go, somebody can write it in Rust. If you write it in C++, the number of people that can read C++, I mean, there's a lot of idioms in C++ that just don't exist in other languages. Very, very difficult to translate that, especially when, Anyway, so having, no matter what type of developer you are, you should have the tools available in the language you're writing in. And if that means that we need, we want to support 5 languages, we need to rewrite it 5 times, that shouldn't be a problem. I mean, especially today with GPT, you just plug in a function, and if the function's written well, you can say, translate this function to Python, and it can do it, So as long as things are small enough and contained enough, we can get to a point where, writing it in another language isn't like, oh, this is going to take 3 months. I mean, I ported this thing in 3 weeks, right? So and that's because it hadn't been, well, I say ported, I rewrote it. There was no reference implementation.
Right.
There was
not a nice, easy standalone reference implementation of just the CoinJoin feature. You had to kind of go monkeying around in wallet software and all sorts of other things as well. All right.
And so for this does have like the last 2 years worth of various libraries. This is a culmination. This has -HD, -TX, -keys. There's several libraries that are each built in that way that I described, where they're isolated along the boundary of the logic of the protocol or the whatever it is. So this actually is a full wallet, but the wallet is not general purpose. It can only do one thing, which is denominate coins for CoinJoin and then participate in the collateral and the CoinJoin process. It doesn't even do PrivateSend.
Is this going to combine with the wallet that we were showing last week, Ryan? Or are they going to integrate with it in some sense? How do these things fit together? If they
that is a future roadmap issue that we'll talk about after AJ does this. But that is the intention, is that we would implement CoinJoin into the web wallet now.
All right, cool. Just trying to get the bigger picture here.
Yeah, we'll talk about that in a bit.
Great.
So here I'm going to run this thing. It's called RPC because that's what I called it when I originally started it. But it doesn't matter.
Pretty cool.
I'm just gonna run this, and then the double quotes is because it's an empty string. This is the default wallet. This is an unsalted wallet. And then in another window, I'm gonna run a salted wallet that's called foobar. So they both come from the same seed phrase, but one is given no salt, which is what normally happens in your mobile app or whatever. Typically, you don't choose the salt, and then this one is given a salt. It's a part of the wallet spec that is used for situations like this, but not used very commonly in practice. But anyway, what it does is it gives us one wallet that can have an infinite number of addresses and completely different histories. And unfortunately, this is not going to make any sense because it's just a bunch of handshaking stuff, and at the end, it's going to say success, it worked. But I'll go ahead and hit enter here, and then I'll hit enter here, and then I will turn on the logger here, and then we can see that it's connecting. It's sending a bunch of messages. I've got a bunch of debug out for the different pieces. So when I said this is 12-step handshake, so it starts with there's actually a handshake that's not seen here. That's to connect to the server, just the connection handshake. Then there's the version handshake.
Server meaning the master node.
Yes. In this case, it's not the master node yet. Well, yes, and there's the master node. So yes, there's that too. So you connect to your Dashcore server, and then you get the list of master nodes, then you connect to a master node, and then you start the master node handshake, and then you start the DSQ handshake, and then you start the CoinJoin handshake. So bunch of different stuff going on here, and you can see there's just a bunch of different messages where they're called command messages, and so there's version, verax, send adder, mn auth for master node auth, and then there's a bunch of hexadecimal byte sequences because this data doesn't make sense. There's not a way to translate this into English other than to log out, what I sent to coin, whatever. So there's a bunch of messages. This is what a collateral message looks like. That's just a normal transaction. There's nothing really special about it except for the amount that's given as a fee, which you can't even see because the fee is just the input minus the output. and then it goes through the DSQ message, which is kind of the masternode had accepted something. DSSU are these status updates that come intermittently. There's a ping and a pong message. And then, it's just all debug information. So it's, there was a lot to sanity check during this process to make sure, okay, am I actually sending the right thing? Am I getting the right thing back? And then it goes and it goes and it goes. And there's a 15-second wait at one point where it's waiting for anyone else to join the session. And
the video just explained, Amanda's video.
And then
for other people to participate in this process.
Yep. So in
your case, you are performing that. You're both participants.
Yep. And so it just goes through a bunch of messages, sends them back and forth, and all this debug information is out because I had to check things byte by byte and make sure, okay, is this the right stuff? Are the right coins getting selected from the wallet? I mean, I'd say that with CoinJoin, 80 to 90% of what you're doing is just like tedious wallet setup. Because you have to have an entire wallet set up with all the coins and everything before you can get started, and all of your coins have to have matured to a minimum degree. So to do this on RegTest, you actually just, like, instead of waiting for stuff to be mined, which stuff is mined a lot quicker in the RegTest network, but instead of waiting for stuff to be mined, you actually send the masternode a message just saying, like, okay, mine 100 blocks so that we can mature these coins and stuff. So there's a lot of tedium that you have to go through. The protocol isn't so bad, other than that there's multiple parts of the protocol and not all of the documentation is in one place. There's at least 3 different pieces of documentation that you need to have a very clear understanding of to implement the whole thing. Well, maybe 4. Anyway, there's a lot of stuff to reference, and I guess because it feels like it's duplicate, because, it's documented over here, it's documented over there. Not all of it is in the CoinJoin documentation, but because it's not all in the CoinJoin documentation, it's not referenced. Like, if you don't know where to go to get the other pieces of documentation, you can easily miss that you even needed them, and then think, I'm sending all the messages. What? So there's tedium there. But at the end, I get a DSC, and DS stands for dark send. So all of the messages start with DS. There's DSA for, it's actually request, but it's called allow rather than request, which is a little counterintuitive because you think like the masternode allows, but it's actually the client that sends an allow request. So there's DSA, and then there's DSQ, means accepted into the queue, and then there's DSF, which again is a little counterintuitive because it's called final, but it's actually the draft. So it's the draft message that you then need to sign, and so then you send a DSS, which is the sign. So it's dark send allow, dark send queue, dark send final, dark send sign, and then the dark send status update and some other stuff. And then DSC is dark send complete, and that's what signifies that your message was completely and utterly accepted, validated, verified in every way, and broadcast, or is queued for broadcast. And so we get that at the end, and then I print out sweet, sweet victory. So again, it all looks like a bunch of nonsense. It's a bunch of hexadecimal representation of these messages that are broken down, like this, with what's the signature type, what's the public key, yada, yada. And then that all gets encoded and sent in binary over the network. So, it's convoluted, it's confusing, it's difficult to understand for anyone, not just a programmer as well. That's kind of the nature of the design. There is a level of minimum complexity. Sure, could you make it a little simpler? Yeah, kind of, but there's a minimum complexity that you just can't avoid. So it's not like I made it convoluted or that the people who designed it made it convoluted. There's a minimum complexity that
it's just a hard
exists.
problem.
Yeah.
You're communicating, and you have to coordinate with lots of different people, and so there are lots of different steps along that coordination. You'd see the same thing if you were logging everything that was happening when you make a HTTPS request. It's just a complicated thing. So anyway, I wanted to jump, unless you had anything else to say, I wanted to jump to what's ahead of us still. What do we need to do before this is useful for just a normal user?
I did want to show one thing, which is the proof. So this is the log of the masternode that I'm connected to. And so, because anybody can just throw a bunch of stuff on the screen and print a success message, and it's like, yeah, look, it worked.
Yeah.
So this is the actual proof that it worked. These are the logs from the masternode. So, you can tell I'm not just blowing smoke.
Granted, these are masternodes on your own little
the reg
test network. So the next step to jump into that would be we need to get this working on Testnet to see if it's actually working with Testnet masternodes. And then the next step would be to get it working on Mainnet. And then, so this is a library that's written with Node.js.
It is a library that is written with web crypto and typed arrays. So the only part about it that's Node is the -RPC library is not yet ported over to be browser friendly, and even when it is ported over to be browser friendly, there's some security concerns with RPC that were never addressed, and so the workaround is to set up a proxy server for it. But I don't think there's the only code that can't run in the browser is the masternodes do not yet expose RPC for CoinJoin. If you look at the RPC documentation, you'll notice there's not a single word about CoinJoin in there.
Mm-hmm.
So since they don't yet expose it, the only way to connect is over TCP. That fundamentally cannot be done in a browser and requires a proxy server. But the code itself is not written as server code. It's written as browser code, but the browser code happens to run on the server. Aside from that one TCP connection, which there is no other way about it.
And our infrastructure is using an insight server anyway to do address lookups by index and things like that. So we don't necessarily need a server independent implementation yet. But I did also just want to mention that there are libraries that will expose the ability to talk directly to servers from browsers. libp2p comes to mind. Anthony, you may know a little bit about that.
Well, I'm kind of just Googling around for this right now. It sounds like things like WebSockets, WebRTC, and Fetch operate at a level above TCP. So basically, it's like a security thing. They just don't want you to do TCP in the browser. So that's kind of what it is referring to, it sounds like.
But I do think that there are workarounds if we want to go down that path, but that is not a path that we need to even think about right now.
Well, the simplest path is just a proxy, and I'm opposed to the complexity of some of the other solutions, because at the end of the day, you're still using a proxy. It's just instead of using a proxy you trust, you're using a proxy you inherently don't trust, and then just using a lot of them, hoping that even though you don't trust any of them, in aggregate, they're trustworthy.
Yeah. And so that's a topic for another day, of course. But let's talk about, so right now, I don't know if I should bring this up right now, because it's a little bit of a deep rabbit hole, but I'll just mention that it's likely that we will be submitting a supplementary proposal. It will probably come from JojoByte for the incubator. We haven't finalized that plan, but if we want to continue working on this, getting it working in Testnet, getting it working, which shouldn't be hard, like Testnet should be fairly easy.
It technically does work in Testnet already. If I were to switch the IP, if I were to connect to my Testnet server rather than my RegTest server, the only reason it wouldn't work is that I have to get with RegTest, I can generate money for myself. Like I can just cause the blocks to be created.
Yep.
With Testnet, I actually have to get the money from a faucet. And so that's a little bit more difficult to do programmatically in a test scenario, because you have to manually go get the money from the faucet. But aside from the step of I have to get money in the normal way rather than generate money as part of the testing tools, it's the same. Testnet is the same. And then, of course, the difference between test and prod is the magic byte for the network header. and that has already been tested for the tools that this is on. So I have absolutely zero concern as to whether or not this will work on Testnet and Mainnet. Like I have 100.0% confidence. I have no lack of
Famous last words.
Well,
Yeah,
I mean,
I don't either. I think it's pretty straightforward. The biggest thing, the biggest challenge will be integrating this into the wallet, the web wallet that we did talk about last week, Anthony. That is not super straightforward because it requires UX development, user experience development.
I don't know that it does, other than a checkbox. Because you don't need UX for any of this handshaking process. The only UX
no, I
is,
get that.
do you want to select the coins or not? Like, it's basically, the UX is coin control. That's the UX.
Yeah.
Well, there's always a UX if we're talking about, like, are we talking about developers? We're talking about, like, users. Like, who is this for? Who are we exposed to? If we're exposed to the users, there's always some amount of UX because people can mess up anything. You know this, AJ.
Well,
yeah, it is going to be a little bit harder than I think that you think, AJ. And regardless, it's going to take some of Jojo Bytes' efforts, a lot of Jojo Bytes' efforts.
No, and this is not a process where I can hand a library to Jojo Byte and, like, here, you don't have to learn CoinJoin. You know, yeah. I can abstract away a lot of the handshaking, but CoinJoin is not, I mean, like Amanda said, it's not an intuitive process. It's not like, and none of cryptocurrency is. None of cryptocurrency is intuitive. Sure. All of it is arbitrary decisions that could have been made one way or another way. It's not like a natural funnel of, like, oh, this is what we arrived at because the laws of nature dictate that this is the model we should follow. It's all arbitrary in the sense that many choices could have been valid choices, and a lot of the choices people made were because they wanted the complexity, because it gave the appearance of, so
I would just, to play devil's advocate, I would point people to Gwern's post "Bitcoin is worse is better," I think is what it's called. That kind of takes the opposite position of what you're saying, but it's a huge rabbit hole, so we shouldn't really go down that.
Bitcoin's worse is better? I'll check it out.
Yeah, I think you'll appreciate this blog post. Actually, this is it's very, very interesting. So when people here,
send a link to it on the screen
another time.
There you go. Mm-hmm. Bitcoin is worse is better.
Because it's the question of, like, worse is better in general is this, like, idea in programming that you end up at things that seem worse because they organically grow in a way that allow them to function in the way they do, that have certain guarantees built in that would be hard to, like, ivory tower think of from the first place. Like, how can I do this perfectly? You can't get there. You need the worse is better approach to get there. So this is an argument for why you end up there.
Yeah, and I will say also to that point that if you tried to understand the traditional monetary system from start to finish, it's much, much more Rube Goldberg-y and complicated and complex than cryptocurrency. So
yeah, we're talking about the Fed. I think they're on par.
Oh, it's worse. Trust me. I've tried to follow both industries in parallel. It is not easy to understand how the monetary system works.
I get that.
It is easier to understand how cryptocurrency works.
It's easy to use an API for a credit card. That is easy.
Yes.
That is objectively easy. There's no security. There's no security. There's no encryption. There's no validation. It's like you send a number and you get money.
Your private key is 3 digits on the back of the card.
Yes. You don't know how true that is, or maybe you do. But recently I've been looking at the PCI standard, and that is what it is.
Yep.
All the other digits are public except for there's 3 other digits that are sometimes not public, but in effect they're public because reasons.
Yeah.
Oh.
So I guess we could leave on that happy note. Privacy is normal. Surveillance is not normal. We're trying to bring this a security feature into cryptocurrency, like would any normal person would. And yeah, communication is free speech. Code is communication. So code is free speech. So any parting words, Anthony or AJ?
Just that I learned a bunch from this conversation. This was super interesting. I've seen things like this in some other cryptocurrencies, but this definitely got into the guts of it in a way that I never have before. So yeah, it's cool stuff, and I think the philosophical principles that it enables is obviously very important to all of us and all of us in the community here.
Excellent.
I would
AJ?
like to know if there's anybody, in the comments. Does anybody have any questions or thoughts?
I don't see any other than some emoji thing.
It's probably just a bot.
Yeah. Yeah, we'll leave it there. I'm sure that there will be
advertised. That's not an advertisement
afterwards. So we'll.
No, this is a person. This is definitely a person.
Oh, it is.
Bots don't just post random emojis. They try and get you to come to their porn site.
But don't they do emojis first? I mean, I get bot anyway. Yeah, I get bots all the time to do weird stuff that makes no sense.
Yeah.
All right. Well, we'll leave it there. I'm not exactly sure what we've got coming up next week, but we will see you next week, and it might be Jojo Bite. I'm not sure, but we definitely have some more work to do on this CoinJoin stuff, and we'll see you next week. Thanks, guys.